All right, this is lesson 18, representations of functions. So key concepts. Functions can be written as equations, tables, mappings, ordered pairs, and graphs. Each can represent the same function in a different way depending on its intended use. So tables and ordered pairs. Function tables are tables that include the independent variable, usually x, and the dependent variable, usually y. The values in the table are determined by choosing values for the independent variable and substituting them into the equation to calculate the values for the dependent variable. These values can also be written as ordered pairs in the form x, y. So in example 1, the equation that represents the relationship between the number of hours a student studies x for a test and the student's test score y is y equals 5x plus 15. Create a table and set of ordered pairs that represents the situation. So my solution, choose values for x. It can be any values. Because we're dealing with hours of studying, they should be positive numbers. So choose values for x, 1, 2, 3, 4, etc., and write the values in the first column of a table. Replace x in the equation with each value of x. Then calculate the value of y. Note, if the equation is not written in the form y equals mx plus b, then rewrite the equation in that form. So I have 1, 2, 3, 4. I substitute those values in. I solve, so I get 20, 25, 30, and 35. The table will only include the x and the y values, so these values and these values, as shown below. The value from the table can also be written as ordered pairs, as shown below. Each row in the table represents an ordered pair. Therefore, the first ordered pair is 1, 20. Mappings. A mapping is a diagram that visually shows the relationship between the domain and range. The domain is listed in one oval and the range is listed in the second oval. Arrows are drawn from the x values to the corresponding y values. So in order to create a map of this, I have my domain 1, 2, 3, 4, and my y values 10, 20, and 30. Okay, so 1 goes to 10, 2 goes to 20, 3 goes to 30, and so does 4. Okay, so this actually shows me. So draw an arrow for each of the domains so it's associated range. To create an ordered pair or table from a mapping, read the mapping and create ordered pairs. So for example, in the solution from example 2, the ordered pairs are 1, 10, 2, 20, 3, 30, and 4, 30. Graphs. While there are several ways that you can graph a function from other representations, one of the most common methods is to plot the ordered pairs. Function maps and tables provide the coordinates. Graphs are also be created from equations. See lesson 20 for more information. So example 3, create the graph that represents the function shown in the table. Since the table provides the x values and y values, the ordered pairs that represent the functions are -2, 4, 3, 5, 4, 1, and 0, -3. Plot these values on the coordinate plane as shown below. So -2, 4, 3, 5, 4, 1, and 0, -3. Converting graphs to other representations. The previous example demonstrated how to create a graph from a table. However, it's just as easy to go backwards and create a mapping, table, or set of ordered pairs from a graph. When a graph that only contains points is provided, identify the coordinate of each point and write the coordinate in the appropriate form, mapping, ordered pairs, or table. To write the equation that represents a line, we'll see lesson 20. Okay. So example 4, create a mapping that represents the function identified by the graph shown below. So first identify the coordinates of each pair. So in this example, the coordinates are -4, 3, -2, -3, 1, 2, and 4, -2. Convert the ordered pairs into a mapping. So -4 to 3, -2 to -3, 1 to 2, and 4 to -2. Interpreting functions. The Keystone exam requires students to identify what the dependent and independent variables represent in a problem-solving situation. The independent variable, usually x, is not affected by the dependent variable, which is usually y. However, the opposite is true. The y is dependent upon the independent variable, or x. The dependent variable is affected by the independent variable. So for example, the number of items that are purchased affects the total cost of the items, but the total cost does not affect the number of items. Therefore, the number of items is independent and the cost is dependent. The Keystone exam will use variables other than X and Y in word problems, just so you're aware. So example 5, a printing company charges for books and adds a delivery fee. The cost C in dollars to have any number of books B delivered to a home is described by the function C equals 10B plus 7. Which statement is true? A, the cost of 10 books is $7. B, the cost of 7 books is $14. C, each book costs $7 and the delivery fee is $10. Or each book costs $10 and the delivery fee is $7. So according to the problem, C represents the total cost of any number of books delivered, and B represents the number of books. Since the total cost C depends on the number of books B ordered, C is the dependent variable and B is the independent variable. We can use this information to evaluate each of the answer choices. So for A, the cost of 10 books is $7. This statement tells us that B equals 10 and C equals 7. Therefore, replacing B with 10 and C equals 7 in the equation, 7 equals 10 times 10 plus 7 is not true. So A is not correct. The same can be said for B. Okay. C says each book costs $7 and the delivery fee is $10. Since B represents the number of books, according to the equation, each book must cost $10 because C equals 10 times B plus 7. And 10B provides to cost all of the books, including the shipping charges. Therefore, C is not correct. So the only answer that I'm left with is D. Each book costs $10 and the delivery fee is 7. Since B represents the number of books, according to the equation, each book must cost $10 because C equals 10B plus 7. And 10B provides to cost all the books, excluding the shipping charges. Additionally, the shipping charge is $7 is only charged once. Therefore, D is correct. All right, go ahead and work on the exercises below, and that is the end of lesson 18.